In this, we will discuss the two definitions and example of functions. Natural domain and real valued function. So when domain is not restricted by context, the domain is assumed to be the largest real set of real number, real x values for which the formula gives the real y values. Okay, as I say that also described it in previous lecture that when we will not restrict the domain and give all the possible values to R, we can say that that is a natural domain. Suppose radius belongs to all the real values, then we can say that it has a natural domain. This function has a natural domain. And what is a real valued function? When the range of a function is a set of real numbers. Suppose I am taking an example as y is equal to x. We can put any value in x, we will get the same value, the same real number values as a range values or the value of the function. That is called as real valued function when the range is also the set of real numbers. Now we are going to describe the examples of functions which has different domain and range. Suppose I am using the first, that is y is equal to x square. In here you can see that we can put any value of the real numbers, either it is in negative or a positive value. But you can see that we will always have a positive value when we are taking the square of a value. So our range lies from closed bracket of 0 to positive infinity. And then here lies our circle bracket. In the next example, you can see that we cannot put the value 0 in our x. So domain also doesn't contain the value 0. So we can put any negative value or any positive value. But in both conditions, we cannot put 0 in any way. Or you can also have range that doesn't contain 0 in it, but it may have negative or positive values. So if we put, suppose if I put 1 over 0, that will contain an undefined value. So in next, there is a function that is equal to y is equal to square root of x. And in square root, you know that You should not put any kind of negative value in it. Only positive values, or you may put 0 in it as well. Okay, then the same is our domain and range values. Because if we put negative, that doesn't satisfy the condition of square root. So second is also example of square root, that equals to square root 4 minus x. It's a bit tricky, but not that much. Suppose if I take x is equal to 4, we will get an answer 0. That is equal to y is equal to 0, and that is our range. And you know that if we put any positive value greater than 4, we will get a negative value inside the square root, and it will doesn't satisfy the condition of square root. Suppose I am doing it for you. I am taking 4 minus 5. Any greater value than 4 will doesn't make our solution right. And here is our minus n that lies in our complex values. So if we put 4, we will get an answer 0, and we can put any value of negative, then we will get positive answers that is truly lies in our range. So next and the last is y is equal to 1 minus x square. I am using the space over here. Y is equal to square root, and again we should have a positive value inside of it. And you can see that we can take negative value in a square as well. But suppose if I take any negative value that is greater than 1, then it will make the solution wrong, because it will make negative value inside the square root, and that will be a bit problematic for us. And you can see that is our minus 3, again a complex value, so it doesn't lies in our domain. So if we put minus 1, 0 and 1 and any other value that lies between minus 1 and 1, we can get a range. Suppose if we put 1 over here, we will get 0, and if we will put minus 1 over here, we will again get 0 that lies in our range. And if we will put 0 over here, me raise it so that you can understand it. And if we put 0 over here, we can get the value of range, that is 1. So in this way, we have done 5 examples of functions and that describes our domain and range.